How to find equivalent fractions. So the first thing is think about what equivalence means. Equivalence means that something is equal to it. So what we've got here is we've got a half is equal to something over 4. Now finding equivalent fractions is a very, very important part of understanding fractions, and you'll use equivalence in a lot of different situations to help you with fractions, decimals and percentages. So it's a really, really fundamental thing that we need to understand. One of the key things is whatever you do to the numerator, that's the number at the top, you must do to the denominator, and vice versa. So if you swap that round, whatever you do to the denominator, you must do to the numerator. So what we need to do is, if you take the first one, this is a nice easy example, you've got to work out how we get from 2 to 4. And as the number's increasing, it's going to be working out what we multiply 2 by to give an answer of 4. So it's all about times tables. So we've got here 2 multiplied by something is 4. So it's multiplied by 2, so we just go through the 2 times table. 2, 4. 2 lots of 2 is 4. So whatever I do to my denominator, I must do to my numerator. Therefore, I do 1 multiplied by 2. So the answer here is 2. 1/2 equals 2/4. Let's look at that visually. So I've got my 1/2. Colour that in. And I've got my 2/4. And you can see visually how they are worth the same. I'm just going to also show you something you can use if it helps you. You can use a fraction wall, and these are available on the internet. Just go into Google and type fraction wall and you can download one. So here we've got our half, and you can see it's the same as 2/4. It's 1/4 and 2/4. You can see that line lines up with that one. 2/4 is the same, it's equivalent to a half. Right, let's look at another one. 2/3 is equivalent to how many ninths? Again, it's all about times tables. So we've gone 3 multiplied by something equals 9. So we go 3, 6, 9. 3 times 3 is 9, so we're multiplying by 3. Therefore, we need to do 2 multiplied by 3 is 6. 2/3 is equivalent to 6/9. Let's have a look at colouring that in again. So here's my 2/3. And I've got 1, 2, 3, 4, 5, 6. You can see the amount of space there is the same here. 2/3 is the same as 6/9. They are equivalent. Just a little look on our fraction wall. Here is our 2/3, 1/3, and another third. That's 2/3. And there's 1, 2, 3, 4, 6. Let's look at one more. 3/5 equals 6 over something. So here we need to look at the numerator. How do we get from 3 to 6? 3 times 2 is 6. Whatever I do to the numerator, I must do to the denominator. So I times 5 times 2 is 10. So 3/5 is equivalent to 6/10. And finally, 5 multiplied by something equals 20. 5, 10, 15, 20 times by 4. Therefore, I must do 6 times 4 is 24. So 5 over 6 is equivalent to 20 over 24, 20/24. Let's look at a question that we might get written in a slightly different way, but will still require us to think about equivalent fractions. Circle the 2 fractions that have the same value. So this is a type of question that isn't set out like the first one, but still needs you to ask equivalence. So the first thing I would do probably is look at the easiest fraction, which is a half. That's sort of the first fraction we come across, isn't it? So let's think about this one. I'm not going to circle it quite yet because we don't know what the answer is. So can we find another fraction that equals a half? A half equals, does it equal a third? No, it doesn't equal a third. A quarter doesn't equal a half. So let's think about 2/10 and 5/10. Try 5/10 and let's try 2/10. Which one of these is correct? So here, 1 times something is 5 and 2 times something is 5. What can we multiply the numerator by and the denominator so it works? Well, we can do 1 times 5 is 5, and if 2 times 5 equals 10, we know these two are equivalent. Yes, it does. So that is the correct answer. This one doesn't work because this is 1 times 2 is 2, but then if we go 2 times 2, we don't get 4, it's 10. So that is incorrect. It doesn't work. When we do the same to the numerator and denominator, we don't get an equivalent fraction. We don't get the same answer. It's not 10, so it's wrong. Therefore, the answer is a half and 5 out of 10. And that makes sense because half of 10 is 5. Right, let's look at one more. Tick the two shapes that have 3/4 shaded. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 coloured in, and we've got 12 out of 16 coloured in. Now, does that equal 3/4? Okay, so we can use equivalence. What do we multiply to make 16? It's times 5, 4. So if 3 times 4 equals 12, it is correct. And it is, look, so look, it works. 3 times 4 is 12, and 4 times 4 is 16. So that one is equivalent to 3/4. And if you look, you can see this is 1/4, 2/4, 3/4. They're coloured in. Let's look at this one. We've got 1, 2, 3, 4, 5, 6, 7, 8. And we've got 1, 2, 3, 4, 5 coloured in. So is 5/8 equivalent to 3/4? Yes or no? Question mark. So this is multiplied by 2, look. But 3 times 2 is 6. So that doesn't work. It's wrong. And the next one we've got, again, we've got the same here as here, so it's out of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that equal 3/4? Well, we know that 3/4 is 12 out of 16 times by 4, but 3 times 4 is 12, so that one doesn't work. And then this one, we've got 1, 2, 3, 4, 4 out of 8, and we know that 4 out of 8 is a half, so it can't be right, but we know it can't be 3/4 because this is multiplied by 2, and 3 times 2 is 6, so that's not right. So I'm hoping that this one's 3/4. We've got 6 out of 8. Does that equal 3/4? 4 times 2 is 8, and look, 3 times 2 is 6. So that is correct. Just to recap on equivalent fractions. Key phrase to remember is whatever you do to the numerator, you must do to the denominator and vice versa. So what I did here is I did 2 times 2 is 4, so I did 1 times 2 is 2, 1/2 equals 2/4. And similarly here, I worked out what you multiply by 3 to make 9. 3 times 3 is 9, so we did 2 times 3 is 6, and I did the same each time. And then remember, if you're a bit stuck, you can use your fraction wall, and remember that equivalence is used on lots of questions like this, where you use your knowledge about equivalence and write the question out a bit like you see it in a question like this. So remember, equivalence is used in lots of different areas of fractions.